Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafizan bin Muhammad Syaril Bakri. My matrix number is cn210018. Today I'm gonna explain you about our lab 4, that is introduction of solar system. We're using a PV system application software. Okay, for question 1, what is a standalone system? A standalone system is a surface power generated system that is not connected to the electrical grid. It contains a solar panel, batteries, a charge control, and inverter. The solar panel converts sunlight into DC electricity, which is that stored in the battery. The charge controller regulator charging and discharge of the batteries to ensure that they are not overcharged or drained. The inverter converts the DC electricity stored in the battery into AC electricity, which can be used to power house application and other electrical device. A standalone system is typically used in remote area where there is no access to the grid or where it is too expensive to connect the grid. It can also be used as a backup power source in case of the grid outage or emergency situation. Next is question 2. What is the component of the standalone system? The first component that used in standalone solar system is solar panel. They are primarily component of the solar system. They capture sunlight and convert into a DC electricity. And then the charge controller. This device regulates the amount of the current that flow from the solar panel to the battery bank. It prevents the battery from overcharge and getting damaged. Next is battery. The energy generated by the solar panel is stored in the battery bank. The size and the capacity of the battery bank depend on the energy needed of the user. Next is inverter. This device converts the DC electricity stored in the battery into AC electricity that can be used to power house application. The next is a backup generator. In case of prolonged period of low sunlight or high energy consumption, a backup generator may be necessary to supply the solar system energy producing. Next is electrical wiring. Solar panel, charge control, battery, and inverter are connected to the electrical wiring. And lastly, the mounting structure. Solar panel need to be mounted on a structure that keep them stable and securely attached to the roof or the ground. Question 3. Draw a diagram to show the connection from the solar to the load. Okay, this is the connection from the solar to the load. The first thing that we have to have is the solar panel. Solar panel are installed in a location where can be received direct sun from the most of the day. The panel are made up of the photovoltaic cell that absorb sunlight and convert into DC electricity. Then it goes to charge control. The DC electricity generated by the solar is sent to the charge control, which can regulate a flow of energy to the battery bank. The charge control prevents the battery from overcharge and getting damaged due to the excess energy. Then the DC electricity from the charge is stored in the battery bank. The battery bank is designed to hold enough energy to meet the user energy needed during period of the low sunlight and high energy consumption. Then the DC electricity stored in the battery bank is sent to the inverter, which convert it into AC electricity Most of the household application and device run on a AC electricity, so that the inverter make the energy unstable. And lastly, the DC and the AC electricity is then sent to the electrical panel of the house or building, where it can use to power the application and device. Next is question 4. Explain the tilt and azimuth angle. The tilt angle, also known as the solar panel tilt, refer to the angle which the solar panel tilt with respect to the ground. The tilt angle is measured from the horizon plane and typically expressed in degree. The ideal tilt angle depends on the altitude of the location and the season. For the azimuth angle refers to orientation of the solar panel with respect to the true south. The azimuth angle is measured in degree clockwise from the south. The ideal azimuth depends on the location of the season. The proper adjust to the tilt angle and azimuth angle of the solar panel can increase their efficiency and improve the overall performance of the solar system. This angle can be calculated using various tools such as solar calculation or with the help of professional installer. And lastly, question 5. What does horizon mean in solar system? In solar system context, the horizon refer to the apparent line where the sky and the earth appear to meet. The horizon is an important factor to consider the designing a solar system, particularly for the solar panel that are mounted on the roof or ground mount. The horizon can absorb sunlight and prevent solar panel from receiving direct sun. This can also result to reduced energy production and the low efficiency of the solar system. The horizon also can affect the azimuth angle, which is orientation of the solar panel with respect to the true south. If the horizon is absorbed by a building, tree or other object, it may necessary to adjust the azimuth angle to compensate the standing. To optimize the performance of the solar system, it's important to ensure that the solar panels are installed in the location where they can receive direct sun for the most of the day and where the horizon is unobstructed. This can be achieved by selecting a location with a clear view of the sky, avoiding area with a tall building or tree, and positioning the solar panel at the proper tilt and angle. Next is for part 2. mesti pakai baca 7 28 sistem run. So okay, close. Thank you.